Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And the topic for today is something called the diurnal temperature range, which is simply a fancy way of describing how much the high and low temperature vary during the course of the day. Now, normally the low temperature will occur maybe around 6, 7, 8 in the morning, and the high will occur 3, 4, 5 in the afternoon. There are exceptions. Sometimes you'll have a massive cold front come through at 11:30 at night, and the low for the day will be at 11:59, but those are the exception rather than the rule. So we're basically looking at how much the temperature varies during the course of a daytime period. So let's go on ahead and miniaturize myself here and delve into this a little bit more. So here are the 30-year averages for the high, the low, and the average temperature for a given day. And again, by looking at that, at least I can't, maybe you can, but I can't tell that there's much of a difference in the distance between the high and the low here than there is maybe down in here. Okay, it looks like they're pretty evenly spaced when you look at it on this sort of a scale. And while we're on this particular chart, and we've talked about this before, you may notice that the temperatures peak here after July 1st, and they minimize, if you will, after January 1st. And you may be asking yourself the question, well, if the shortest day of the year is December 21st and the longest is June 21st, why aren't those on average the coldest and hottest days respectively? Well, the reason is that there's about a 2.5 to 3 week lag. And what happens is that, let's say you're looking at December 21st, after that date, the days are getting longer, there's more incoming solar radiation, but there is still more radiation leaving the Earth than there is coming in from the sun. So the net effect is it continues to cool until the middle of January, and then at that point the sun is getting strong enough to overwhelm whatever the Earth is losing at night, and it starts to warm up on average. Now, same thing in the summer, except in reverse. The shortest or longest day of the year is June 21st, on or about, but there is still more radiation coming in after June 21st than there is leaving until about the middle of July. And so the average temperature continues to go up, and then finally the sun has weakened sufficiently by the middle of July so that on average temperatures begin to cool. Now that does not mean you can't have heat waves in August and September. We all know that to be true. We're talking about on average over a long, long period of time. Okay, so here is the actual range in temperatures between the high and the low on average, looking at the period 1991 to 2020. And we're looking at a difference here between about a 24-degree spread and a 20-degree spread. Okay, so we're not looking at so big of a change that you're going to walk around during the course of a year and say, boy, I noticed the diurnal temperature range is much bigger in March and April than it is in December. I mean, it's just not that big a deal. It's something that geeky scientists tend to look at, and it's just sort of interesting. So you'll notice here that there's a minimum in January and also December, okay? And then there's a maximum range as we head into April and May, and then again in October and November. So why is that? Okay, so what causes a low diurnal temperature range? In other words, a minimum distance between the low and the high. Well, one thing is wind. The wind keeps the atmosphere well mixed, and it does not allow cold air to collect near the ground. We've often talked about the fact that the coldest nights in the winter are going to be when the air is dry, the skies are clear, and the winds are calm. And if there's snow on the ground, that makes it even more effective, although it seems like we've been pulling teeth to have that kind of a situation of late. So basically, if it's windy, it's going to keep or prevent the surface temperature from dropping, and so you're not going to have as big of a range. Cloud cover prevents the Earth's radiation from escaping to space, basically absorbs it, sends it right back down. And the same thing with water vapor. The sky can be completely cloud-free, but if there's a lot of water vapor present in the air, water vapor is a greenhouse gas, a natural greenhouse gas that's been around since time began, and it intercepts outgoing radiation from the Earth and sends it back down to the Earth's surface, keeping us much, much warmer than we would be otherwise. A lot of people don't know that if it wasn't for the natural amount of greenhouse gases, the Earth would be an uninhabitable ice ball. The average temperature of the planet would be 60 degrees Fahrenheit colder than it is right now. So greenhouse gases are not bad in and of themselves. In fact, they are the reason we are here. The question is, how much is enough? And that's a topic for another day, okay? Now, I made up a little table here, And so let's take a look at all 4 seasons. So in the winter, we definitely have more cloud cover on average. We also have more wind. We have low amounts of water vapor. Okay, the air is relatively dry, but the clouds and the wind dominate, and so you end up having a smaller range of temperature during the winter season than other times. Now, during the spring, we have less clouds. We still have a fair amount of wind, but the water vapor is still relatively low. It's gradually increasing, but it's still pretty low during most of the spring. So the fact that there are less clouds and less water vapor are dominating the fact that there's still a fair amount of wind, and so the diurnal temperature range begins to increase. Then in the summertime, we have overall less cloud cover. We also have fairly light winds, and the water vapor is astronomical. Okay, I mean, you all know how humid it can get in this part of the country during the summer months. And so the water vapor is really what dominates. Okay, you would say, oh, well, with less clouds and less wind, we should have a bigger range. But the water vapor is really the dominant factor during the summer months. And then during the fall, we have less clouds, we have less wind, and also less water vapor. So all those things are going into making the range bigger. Okay, so here's the graph that we looked at before. So clouds and wind in the winter months, and then we have less clouds, but it's still dry in the spring, so the range goes up, and then maximum water vapor in the summer months, and so as a result, the range is smaller. The low temperatures don't get down as low as they would if there wasn't all that water vapor in the air. And then finally, as we head back into the fall season, the summer humidity is gone, and as a result of that, more radiation can escape to space, and we get that bigger range in temperature between the high and the low. So that's just sort of a real deep dive. Oops, I forgot there was no slide after that. Sort of a deeper dive into why the range in temperature from the high to the low changes during the course of the year. I hope you found that at least somewhat interesting. All right, that's it for now, folks. That's bonus weather video number 3 for this week. The next bonus video coming up on Monday, and the next daily update coming up very, very shortly. So we'll see you then. Take care, everybody.